Product. We're going to discuss special product. To begin with, we have here the direction, square each binomial, and simplify. So for our first example, we have x plus 5 to the second power, or x plus 5 raised to the power of 2. To expand this binomial, we can have this form. So x plus 5, or it is just equal to this form, x plus 5 multiplied to x plus 5. So you can see here that we have a binomial and another binomial. So to multiply these two binomial, we can use the distributive property. But today, we will discuss, or we will solve this with different method using the FOIL method. So FOIL method stands for F as first, O outsides, I insides, and L for last. So we will use this example. So we will use the expanded form, x plus 5 and multiply to x plus 5. Following the FOIL method, we are going to multiply first the first terms. So the first terms are x and x. These are the first term. So x times x is equal to x squared. Next is the outsides. The outsides are the terms that are found outside. So we have x and 5. So multiply x times 5, the result is 5x. Next, we are going to multiply the insides. So if we have the outsides, the insides are 5 and x. So these are the insides. The answer will be 5x. And last is the last. So we will multiply the last terms. So we have 5 and 5. The product is 25. So as you can see, the middle terms are like terms, so we can combine them. Copy first the first term, x squared, and then combine. So we are going to add 5x plus 5x. The sum is 10x. And then copy 25. And this is our answer. Again, the result the result is x squared plus 10x plus 25. So a in squaring a binomial, the result is a perfect square trinomials. This belongs to the special product. So in order to make it faster or easier to answer this kind of special product, we are given patterns to follow. So we have here a plus b squared, or a plus b to the power of 2 to the second power is equal to a squared plus 2ab plus b squared. And if we have a minus b to the second power, it is equal to a squared plus 2ab plus b squared. So, using our example number 1, x plus 5, we are going to use this pattern. And let us compare later if we come up with the same answer. So we have again x plus 5 to the second power, or we have the second power. So this first term is our a. The second term will be our b. Following the pattern, we're going to square the first term. So x times x is x squared plus, we have twice the product of the first term and the second term. So we'll put 2 and then multiply x and 5 plus the square of the second term, or b. So 5 times 5 is 25. Not 5 times 2. 5 times 5. Okay. So, simplify, we have x squared plus 2 times 5 is 10. Copy the variable x plus 25. So we have x squared plus 10x plus 25. And with our answer a while ago, we come up with the same answer. So this is a short way to answer a square of binomials. So if we are just going to observe, if we have this kind of pattern, this kind of binomial, automatically we can use this one. Or for example, we have this the difference of AB then squared, we can use also this pattern. Now let's have another example for the two patterns. So we have here, so I put the pattern above. So we have example number 2, x plus 10 raised to the power of 2, or x plus 10 to the second power. Okay, so first we are going to square the first term. So if you are still confused, you can mark x with a and then 10 with b. So we're going to square the first term, x squared plus, okay, write the 2, twice the product of the first and the second term, which is x, and 10 plus the square of the second term, which is 10 times 10. And after that, we are going to simplify. So x squared, copy x squared. And then we're going to multiply 2 times 10. The result is 20x. And we have 10 times 10, it's 100. So as you can see or observed, our first term and our last term are perfect square. So maybe that is why it is called. That's why the result of these square binomials or squaring binomials is called perfect square trinomials. Next, we have an example for this pattern. So we have 2. So again, we'll mark the term 2x as A and 5 as B. So following the pattern, first we are going to square the first term. So we have 2x squared. The next, copy the sign, minus 2 2 times the product of the first term, 2x, and then the second term. After that, the last piece is b squared, or the square of the last term, which is 5 squared. So if you can do this mentally, you can, like, for example, in the first part, you can directly put 4x squared, but I will show you how to make it in a step-by-step way. So 2x squared is equal to 4x squared. Copy the sign and then multiply 2 times 5, 10 times 2x, it's 20x, plus 5 times 5, it's going to be 25. So this is our answer. 4x squared is 4x squared minus 20x plus 25. Now let's proceed to the other special product. So if you find this kind of pattern of binomials, we have this is a product of a sum and a difference. So the pattern of this binomial is equal to a squared minus b squared, or the difference of squares. The difference of squares because we have the operation of subtraction. Then squares because the first term is a perfect square and the second term is also a perfect square. This is only applicable if we follow this pattern. So for example, we have x plus 2 and then x minus 2. So we're going to check if the first term are the same and the last term are also the same, but their operation is opposite. So we have plus and minus. Therefore, we can use this pattern. So all you have to do is to square the first term, a x squared, and then copy the sign, then square the second term, which is 4. Okay. How about if we are not going to use this pattern? We are going to solve it using the distribution or distributive property. So we can check if the answer is still, if our answer is still the same. So we have x plus 2 multiply to x minus 2. So first, we are going to distribute the x, or you can also use the FOIL method. So x times x, it's x squared, and then x times the outside, x times negative 2 is negative 2x, and then the insides, we have 2 and x plus 2x, and we have the last term, 2 and 2, it's negative 4. Now, we observe that it has like terms. And the like terms have the same numerical coefficient and variable, but they have different sign. Therefore, we can crush them because they are just going to be equal to 0. So, removing this 2, what remains is x squared minus 4. So, it is just the same. So what about if we are given the difference of squares and we're going to find the binomials. So simply we're just going to follow the patterns. X plus, so we're going to square 16. So the square root of 16 is 4. The square root of x squared is x. So x plus 4 and x minus 4. So this will be the answer. So there are some case that the given is the difference of squares, and you are going to find the binomials. So automatically, if you find this pattern, it is easy for you. Would be all. Thank you.